Welcome back to the Inventory Remake series. In this episode, we'll finish the UnregisterItem function we started last episode, and we'll also set up the display on the client side to actually show the current items in the inventory and update it when items are added or removed. If you have any questions as you progress through this series or any other of my videos, feel free to join the Discord server in the description below for access to specific channels where you can request help with your code. Now we'll get back to the UnregisterItems function. Inside the for loop we created, we'll create a variable setting it equal to table.find stackdata.items, tool, which will search the stackdata.items table for the tool object and return the index it was found at or nil if it wasn't found. We'll create an if statement to check if found isn't nil, and then use table.remove stackdata.items, found to remove that specific index if it was found. Then we'll add another if statement inside of that which checks if the length of stackdata.items is equal to 0, and does essentially the same thing we did to remove the item from the stack, but instead remove the stack from the inventory. Since the stack will always be found, we don't need to check if found2 is nil or not, and can just run table.remove to remove the stack from in.inventory list of stacks. This chunk of code, overall, will effectively remove the item from any stacks it's found in, and then remove the stack if the stack is now empty. Next, we'll just do some organization with the comments just to make the code easier to read through. Then, since we'll always find the stack in the removing stack portion, we don't need to create a variable for found2 and can instead just put the table.find directly inside the table.remove to save us a couple lines. At the end of both the register item and the unregister item functions, we'll print the inv.inventory so we can see what it looks like as items are registered and unregistered. When we test, we can see that it prints a bunch of times as it registers my current items. This should work the same as in the last episodes, as we haven't changed the register items code at all. But now, if we remove items from the player's backpack in server mode, it should print again, this time removing our items from the inventory as we delete them from our backpack. If we delete all the items in our backpack, you notice the inventory simply becomes empty. Since it works, we'll remove our prints we added and make a new function in InventoryServer called getInventoryJSON, with the player as the first parameter. At the top of our code, we'll get the HTTP service, and in getInventoryJSON, we'll return hs:/JSON encode InventoryServer.allInventories player closing bracket. HTTP service JSON encode basically takes a table as an argument and converts it to a JSON string. This is mostly important for saving and loading the inventory more efficiently, but we'll also use this function to get data on the client. At the top of the getInventoryJSON function, we'll add a while loop that essentially waits until the player's inventory is added into the allInventories table, just in case this function is ever ran before the inventory is actually created in the player-added function. We'll move this getInventoryJSON function to the bottom of our code, just above the start function, and then in the start function we'll use signal to listen to remote fires from the client using signal.listenRemote, providing the key inventory:getInventoryJSON and connecting it to the InventoryServer.getInventoryJSON function we created. This will essentially function the same as a remote event or remote function in this case, allowing us to run that specific function from the client and retrieve the inventory JSON string so that the client has access to the inventory. Note that at the time of recording this video, I was convinced for some reason that you couldn't pass tables or instance references from server to client or vice versa, hence why I passed the JSON encoded string instead of the inventory table itself. But I was mixing up tables with metatables, as you can pass tables across the client-server boundary just fine, but metatables are lost if there are any. Point is, it may be more effective later down the line to create a new function for the client to get the inventory data, calling it just getInventory rather than getInventoryJSON, and then returning the player's inventory. This would allow you to actually reference the tool objects themselves rather than just their information, but the functionality of the inventory remains pretty much the same either way, so if you don't know how to do that, just keep following along. Now, in the inventory client module, we'll create a new value inside the inventory client called invData, setting it to nil to start. We'll then create a new function called InventoryClient.updateInventoryData. At the top, we'll get HTTP service like we did in the server module, and then in the updateInventoryData function, we'll set the InventoryClient.invData to be HTTP service JSON encode signal.invokeServer InventoryClient getInventoryJSON. Now that's a lot to take in, but it basically invokes the same key we made earlier, getting the return value from the inventory server's getInventoryJSON function we made, and then passes it as an argument into HTTP service JSON decode, which turns the string back into a table. In the start function of the client module, we'll run the updateInventoryData function once upon starting, and then connect a new function to the inventory:"items_updated" signal key, allowing us to run it from the server module at any time. The function will have just one parameter, which will be the new inventory data. I would just connect the signal key to the updateInventoryData function we made already, but given that updateInventoryData makes a call to the server to update the data, whereas this method already comes from the server, there's no reason to add an extra remote fire across the server client boundary, as it just adds unnecessary delay. In this function, we'll basically do the same thing we did in update inventory data, but using new inv data as the argument to JSON decode rather than getting the inventory data by invoking with the signal module. Next, we'll create a new function called InventoryClient.UpdateDisplay. The positioning of these functions doesn't matter too much, but for organizational purposes, we'll move that up to the top so it's easy to see when we open the script. We'll call this function right after updating the inventory data, and then call it again in the function we connected to the inventory:_items updated signal key. The updateDisplay function will essentially be our refresh function, to refresh the inventory display. First, we'll clear all the current item frames in the item scrolling frame so long as they're image buttons and they aren't the sample frame. For each stack in the inventory, we'll create a clone of the item sample image button we made, setting the name to be the name of the item from stack data and then the image to be the stack's image. Given that we've JSON encoded our inventory and passing it to the client here, the inventory table module will no longer have proper references to the tool objects themselves, and so the items value inside each stack will no longer function as intended. To account for this, we'll adjust the getInventoryJSON function, making it alter a copy of the inventory just before passing it to the client. We'll create a new variable called adjustedInv, adding an inventory table inside of it. We'll then make reference to the player's actual inventory for ease of use, and create a hotbar table inside adjustedInv, setting it to be the actual inventory's hotbar, as we only need to adjust the inventory table. We'll do the same for the armor table and the last stack ID to create a full shallow copy of the inventory. We'll then run a for loop through everything in inv.inventory in order to copy and adjust each stack into our adjustedInv table one by one. We'll insert a new table into adjustedInv.inventory and essentially copy everything from the registerItem function that creates new stacks, but adjusting the values to match the actual stack. The one value we will change in this for loop is the items value, removing it entirely and replacing it with a count value, which we'll set to be the number of stack data items. Everything else will remain the same as stack data. After creating this adjustedInv copy of the inventory, we'll replace what we had inside our JSON encode with adjustedInv, returning the JSON encoded string of our modified copy of the inventory rather than of the inventory itself. This will also make saving easier, as it gives us a count value for how many of a specific tool to clone into the player's inventory when loading their inventory data. Back in the InventoryClient.UpdateDisplay function, we'll set the item frame's count text to be stackdata.count, which we just added to the return of getInventoryJSON. Then we'll set the parent of the frame to be the item sample's parent, add the letter X at the end of the count text for display purposes, and set the .visible property to true so we can see the item in the item scrolling frame. Afterwards, we'll add a small note to connect the item selection code once we make that. For now, we'll test it and see if we get an error, which essentially is saying that InventoryClient.InvData.inventory is nil whenever update displays first ran for whatever reason. To make it easier to test the client's version of the inventory data, we'll add a print inside update inventory data that prints the InventoryClient.InvData. This error, however, is actually because inside the InventoryServer module, I accidentally inserted each adjusted copy stack into the adjustedInv itself rather than adjustedInv.inventory. Fixing that, we can see that the error is gone and our client inventory data seems to be correct. We can even see that the items load in the inventory scrolling frame, even with the count text in the image and whatnot. If we remove items from the inventory, however, it never actually updates the display because we never fired the signal we connected on the client earlier. In registerItem, we'll run signal.fireClient with the key from earlier, and we'll do the same in the UnregisterItem function as well. Also make sure you provide the player as the first argument of fireClient, which I forgot to. At this point, I also come across a bug with the signal module, which has been fixed in more recent versions. Finally, I also forgot to provide the InventoryJSON data as the first and only argument in the signal.fireClient calls in the registerItem and UnregisterItem functions. Trying it again, you'll notice it works roughly the same as before, but now when we remove items from the inventory, it removes them from the GUI display as well. And when we add items to it, it also updates the display then as well. Thanks for watching, and as I mentioned at the start of this video, if you have any questions with scripting, feel free to join my Discord server linked in the description and on my channel page for access to channels where you can ask questions related to Roblox Studio game development and scripting. In the same Discord, you can gain direct access to the studio files themselves for this tutorial and more simply by becoming a member of this channel for $2.99 a month and connecting your YouTube account to your Discord account. Either way, thanks for watching and I'll see you guys next time.